we'll finish up the notes today for chapter 10. Just a review kind of the periodic table. Remember, columns. These are called groups or families. Families because they share similar characteristics. So I have 18 of those. But these two and these guys over here, the A's, those are ones more that are involved in bonding. So when we talked about valence electrons, these guys have one, these guys have two, three, four, five. It's the A letter, okay? And I don't think that's on the periodic table I had you run off. So anyway, these are the transition. They don't have a specific pattern. So that the B groups and like they don't have three and they don't have four and they don't have five. That's not a thing, but these guys really do. If you look at these numbers, that's how many valence electrons they have. Okay, we have rows. Okay, those are periods. And the atomic number increases as you go across. But they don't necessarily share similar characteristics if they're next to each other here. It's up and down, yes, but across, no. Okay. The period number corresponds to the highest, and we talked about the principal quantum number. So here's your principal quantum number. These two are 1, these two are 2, and so on and so forth. So that's the N, they call it. It corresponds to the highest principal quantum number is your period number, okay? The lettering for the 1 through 18, again, those are the groups, okay? So we have 18 columns up and down, and we have 7 periods, okay? And again, the A groups, those are the representative elements. Those are the ones that are S's and the P's. Those are the ones when we talk about bonding and everything. Those are the ones. The transition, they don't have patterns, so we don't really have a way to label them as far as families and that kind of stuff. Okay, so again, the main groups, these two, and you should have these labeled on your periodic table. These are the S's. These are the P's. Okay, those are the main groups. These are the D's when we did that on your chart. Okay, so we have the alkali metals. Those are not hydrogen, though. Hydrogen shouldn't be in there. These lithium down are the alkali metals. They all have similar characteristics. They're very reactive. They you won't find them in nature in their pure form because they're too reactive. We have the alkali earth metals. They're very, very reactive as well. Not quite as reactive as the alkali metals, but again, they share similar characteristics. We have the transition metals. Then the halogens, we've talked about them, the salt formers. Okay, fluorine, chlorine, bromine, iodine. These guys, when you put them with a metal, form a salt. And then we have the noble gases. Okay, now these guys, if you look on some, they call these the boron family, the carbon family, the nitrogen family, the oxygen family. You know, how much you want to get into it, I guess it's not a big deal. Okay, so magnesium is a member. It's in, if you go back here, here's magnesium, alkali earth metal. Okay. The modern periodic table, again, had to be fixed because when Mendeleev did it, he put everything in according to atomic weight, atomic mass. But there's a couple spots where that doesn't work. I wonder if we can see that. If you look, no, we don't have the mass on here. But these two right here are messed up. This one is lighter, or this one's heavier than this one. There's a couple spots over here. So there's like 4 places in the periodic table that doesn't work. So what they do now is, again, they put the elements in by atomic number, and then they work perfect, okay? The shorthand version of, they call it the noble gas, or the short notation. I already showed you that in the videos. If you should have watched those already. If you have a larger element, they're pretty handy. If you have a small element, they're really not that big of a deal. But remember, you go to the row above, pick the noble gas there, put it in parentheses. That means the same configuration as neon, and then you add on 2 to get to sodium. So this is a lot easier than writing out 1s2, 2s2, 2p6, 3s1. It's shorter. And again, the smaller elements is not so bad, but when you get to those big ones, the ones in the 6s and 7s, it's really handy, okay? And again, you can also figure out this element because sodium's atomic number is 11. Well, if you look, neon is 10 plus 1 would give you 11. So that still works as to making sure that you got the right one, okay? So again, when you're filling them, and I showed you on that chart, after 4s, you think it would be 4d, but it's not. It's 3d. And the reason for that is the orbitals are actually on the periodic table by their energy, not by their number. So when you get in the first level, you have S. You get in the second, you have S and P. When you get to the third, you get S, P, and D. Unfortunately, the D isn't until you get to the 4th period. It's just moved down. All of those transitions are moved down one because they actually have a higher energy. So 4s has lower energy than 3d. But again, if you follow those numbers like I told you to put it in, it won't be a problem. Okay. And again, here's some to show you how to do the noble gases. Okay. You just take, for potassium, it's number 19. You go to the end of the row over here and it would be argon. So you argon, put in parentheses, that means everything the same as argon plus this will give you potassium. So it's a shorthand way of doing it. And again, I showed you that on the video. I'm hoping you guys got that. Okay, so we have the transitions. When you get to the D's, remember you have to write out all 5 of them. There's 5 levels. Okay, you have to write all 5 of those shells down, even if there's nothing in them, because they're still available. The reason why we do electron configurations is to see where electrons are. Well, if there's 5, there's available spots for 10, and I put in 1 and I leave those 4 off, I mean, it's going to look like I have a spot for 1 when I really have a spot for 9. So make sure when you get to a new level, you write all the orbitals available. When you get to the P's, put all 3 of them down, whether there's something in it or not. When you get to the D's, put all 5 of them down. We haven't really done much with the F's. That would be 7. We put 7 of them down. And I don't know if we'll, I mean, it's not that important that we deal with the F's because those are rare earth elements anyway. Okay. So when you're filling them, and like this should be on the chart that I showed you, these are the 1S's, and you have the numbers here. These are all S's, and they correspond to whatever period they're on. The same with the P's. They're all good. The D's are moved, they move down like, so you go 4s and then you go 3d. And again, there's 10 elements, so there's 5 orbitals. And then you go back to 4p, 5s, then 4d. And when you have to move down here, you'd go, because here, from here it would go down here and then it'd go back up again. Again, these are the F's. And even though you're on the 6th level, they're actually 4 because their energy holds them down there. Okay, so just follow these numbers like I told you to write on your periodic table and you'll be fine. The order is always the same. That's Aufbau's rule. Aufbau says you fill the lowest energy levels first. Okay, the other rule we talked about was Hund's rule. Hund's rule is like when you get to these P's, write all 6 of them down, put 1 at a time, and don't double them up till you have to. That's Hund's rule. And the other one is Pauli exclusion. That means no 2 electrons can have the same 4 quantum numbers. That's why we have opposite spins. Okay. All right. The excuse me, electron configuration. Okay, so argon is 18 plus 1, 19. That would be potassium. Again, that's the easiest way to do it, is just add up the numbers. Take the atomic number for this and add whatever the exponents are, and then you'll find your element. It's equal to the atomic number. Okay. Let's see. Here we got neon is 10 and 3, 13. I think that's aluminum. I don't have a periodic table in front of me, but I know my periodic table pretty well. And again, that would be aluminum. Okay. When you're looking at a chemical table, I mean a periodic table, it's called the periodic table because periodic means repeating. Okay, just like the days of the week. Every 7 days, Monday's coming. Okay, so these have repeating patterns. That's where the periodic came from. Okay, because of their amount of valence electrons, and we talked about that. These guys have 1, these guys have 2, 3, 4, 5, 6, 7, and so on. Because of that, they have similar characteristics. That's what they're going to react with according to the number of valence electrons they have. The next chapter, we're going to draw I'll show you how to draw them out. Okay, so the group number equals the total number of outermost. So 7 has 7A. Now, these are the A's. These guys have 1, these guys have 2, 3, 4, 5, 6, 7, and these guys have 8, except for helium. Helium only has 2. Hydrogen and helium are different because they're such a small element, but again, that's where you get it from. Okay, so we're done now with chapter 10.